Chapter 3 in the textbook basically deals with probability, and probability, it's technically it's used to describe the likelihood that an event would occur, something will happen. All right. In statistics, however, when we talk about probability, we are actually referring to a numerical measure. All right, we're referring to a numerical measure of how likely an event would occur in the face of uncertainty. All right, so um, I'm trying to make a prediction using like a value, a number. All right, a prediction of something that I don't have control over. All right, so in the face of uncertainty. So if you take a coin and then you flip it, there is some degree of uncertainty around it because you don't know whether a head may come up or a tail may come up. So that's where the word uncertainty comes in. And here we say a numerical measure because here we are trying to put a number on an event that would occur, and yet there is some degree of uncertainty. For example, when I make the statement that today there is a 60% chance of rain. So here, the 60% is the numerical measure, right? The chance of rain is in the face of uncertainty. I don't have control over the rain, and I'm making some kind of prediction. Okay, so we're trying to create have like a numerical value um, that deals with an event occurring. However, that event itself is characterized by some degree of uncertainty. Okay, now that numerical measure, that numerical number that we want to come out with is between 0 and 1. All right, so probability varies between 0 and 1. Now, probability could be a fraction from 0 to 1. It could be a decimal from 0 to 1, or sometimes we could report it as a percent. In terms of percent, that would be 0% to 1%. Now, talking about probability ranging from 0 to 1, probability ranging from 0 to 1, right? If the probability is 0, it means that that event is impossible, something that will never happen. All right, so if the event would never happen, then the probability will be 0. Now, if the event would surely happen, all right, then the probability is 1. So something that is sure to happen. So we are very sure to happen, right? Then that event, it's 1. So anything that is certain to happen, sure or certain, then the probability is 1. Now, if it's like halfway, it's likely to happen or is not likely to happen, then it has maybe 50-50 chance. All right, so that's 0.5. Now, any probability that is close to 0, it's unlikely to happen. And any so that's close to 0, close to 0 is unlikely to happen. Any probability that is close to 1 is likely to happen. So let's say if I have 0.90 or 0.97, then that is very likely to occur. Now, I can also say that in this case, so talking about things that are unlikely to happen, or sometimes we say less likely to happen, and this is more likely to happen. So we say that if something has a small probability, then it means that that event is less likely to occur. And if something has a large probability, then we say that that event is more likely to occur. Okay, in statistics we say an event is unusual when it has low probability of occurring. All right, so more likely means it's has a probability that is very close to 0, close to 1. Less likely means it has a probability that is close to 0. An unusual event definitely is something that the probability is very low. All right, very low, very low probability of occurring. So, like I said, today's class is going to be more like an English class. All right. So, terminology is one of the first terminology that I want you to know, apart from the word probability. Probability. I want you to know this keyword, a random experiment. All right, a random experiment. So, what is a random experiment? Before I talk about a definition, let me just actually talk about these two first. Rolling an unbiased coin, right? We know a coin has what? One, two, three dice. Sorry, one, two, three, four, five, six faces. Okay, and a coin, for example, is made up of just a head and then a tail, right? Okay, so a random experiment is any repeatable process, something that you can repeat. Like you can roll a dice many times, you can toss a coin many times, you could shuffle like a card and pull out a card many times. All right, so something that is repeatable, all right, in which all the possible outcomes are known. All right, if you're on maybe a sports team, for example, if you're on a sports team and you're going to have a game, you know that you could win the game, you could lose the game, or you could tie, right? You could tie the game. So you know all the possible, so it says all the possible outcomes are known. However, this is a very important part. But, so you know all the possible outcomes, but the occurrence of each outcome you you cannot, cannot be predicted in advance with absolute certainty. So, you're going to play a game. You know that you could win, you could lose, or you could tie. However, you cannot predict with absolute certainty whether you are going to win or whether you're going to lose. Even if you think that it's absolute certainty, it's just some form of belief. All right, it's a chance you are taking. Okay, so when we roll a die, it's an experiment. When we toss a coin, it's an experiment. Okay, so that's a random experiment. So you know all the something, the process is repeatable. You know all the possible outcome that could happen, but you cannot predict in advance with absolute certainty what would occur, what particular thing would occur. Like I can take a coin, I know it could be a head or a tail if I toss it, the result, but I don't know for absolutely which one is going to come up. Okay, and if somebody tells you, they know they are lying to you. So apart from the terminology, the first terminology that we learn is a random experiment. Random experiment. The second terminology that we want to learn, it's an outcome. An outcome, or sometimes we call it a simple outcome. Simple outcome. A simple outcome is a single result of an experiment. All right, so it's a single result of an experiment. So a single outcome is a single result of an experiment. Okay, so when we have, like, we toss a coin, so when we have a coin, we know it could be a head or a tail. All right, so a head is a simple outcome, a tail is a simple outcome, a single result of an experiment. Then another big word that we need to know is sample space. So three is sample space. Sample space. Now, what is a sample space? A sample space is the collection of all the possible outcome of an experiment. All right. So it's a collection collection of all simple outcomes of an experiment. Now, when you say an experiment, of a random experiment, okay, so when we think about, let's say you think about a die, the sample space will be 1, 2, 3, 1, 2, 3, 4, 5, 6, because the die has 6 faces. If you think about a coin, the sample space will be a head, comma, a tail. All right. If you think about like a game, we could, in terms of the game out result, the game could be a win, a tie, or a loss. Okay. Now, usually we use the uppercase S to indicate like a sample space. All right. And then we start with a curly bracket and we end with a curly bracket. All right. These are like curly brackets. Some people call it braces, right? Curly brackets are also called braces. And then you list all the values with a comma that goes with it. So a sample space is a collection of all the possible outcome of an experiment. Now, the next word I want you to know, it's called an event. Now, sample space, think about something like population. Remember when we define population, we use the word all, which will be part of your test one. All right, we use the word all. All right, so sample space is everything, it's all the possible outcome of an experiment. Now, an event is just a subset of the sample space. So event is a subset of sample space. So an event is a subset of the sample space. Now note here, for example, so when we say a subset, it could be one or more simple outcome. So one or more simple outcomes, right, in the sample space. So for example, if we have, let's think about, let me say a die again. A die, we know the sample space. Um, if we have a die, the sample space is S. If you have a die, S is 1, 2, 3, 4, 5, 6, right? Now an event could be something like the even numbers. And usually we use uppercase alphabet to represent an event. So we can say event A. So usually what we write, we could say event A, instead of writing it over there, we could say event A. So event A. Event A is the even numbers. So what you would do then would be to list the even numbers, right? So that's 2, 4, 6, right? These are the even numbers. So you see that these even numbers are coming from the sample space, right? 2, 4, 6. So an event is a subset of the sample space, all right? A collection of it, but not all of it. All right, event is a subset of sample space. So events are represented by uppercase letters. Events are represented by uppercase letters. Okay. Now, as we deal with probability, we will be working a lot with the standard deck of cards, right? The standard deck of cards, we'll be working a lot with it. So I actually went to Google Images to get these pictures for those of you that are not too familiar with the deck of cards, because you will need them. You definitely need them. So in the deck of cards, there are four suits. All right, we have clubs, we have diamonds, we have hearts, and then we have spades. So there are four suits in the deck of cards. There are four suits, all right? Clubs, diamonds, hearts, and spades. Two of the suits are red. So diamonds are red, hearts are red. Two of the suits are black. So clubs are black, spades are black. Okay, now each suit has 13 members, and each member is well labeled. Okay, so when we take something like the diamond, right? Let's take the diamond. The diamond has 13, so there are 13 1-3 members, or 1-3 cards. There are 13 cards in each suit. Okay, um, we have ace. Ace has no number, you just say A. Then you have like the numbers portion. Then you have jack, the queen, and then the king. All right, jack, queen, and king are called face cards because they have faces on it. All right, when you look at the drawing on the card itself, it's like some kind of weird face. So they are called face cards. So jack, queen, and king, they are called face cards. So altogether, every card has 3 face cards. Every suit has 3 face cards. Altogether, there are 12 face cards in the deck of cards. All right, there are 12 face cards. This is another set of face cards. This another set of face cards, and then this another set of face cards. Okay, now ace is not a face card. Sometimes some people say ace is 1, some people say ace 11. It depends upon the rules of the game. All right, depends on the rules of the game. So each one has 13 cards, 13 cards, 13 cards. So that's why this gives you 52 cards. All right, so you don't have to buy any deck of cards. If you could remember the pictures, you should be fine. So I just list the outcomes here to indicate that we have 52 of them, 52 cards, 52 outcomes. So in a deck of cards, there are 52 possible outcomes. Now, let's talk about another terminology. So one, we've talked about probability. 2, we talk about a random experiment. 3, we've talked about an outcome or a simple outcome. 4, we've talked about sample space. 5, we've talked about events. 6, we're now going to talk about equally likely events. Okay, now, so what is an equally likely event? I can bring your mind to when we were dealing with simple random sampling, where we say that every member of the population has an equal chance of being selected into the sample. In an equal likely event, each outcome of the experiment, every outcome of the experiment has an equal chance, equal probability of occurring. All right, every outcome of the experiment has an equal chance of occurring when the experiment is performed. So we can think about it. Let's say if you have a die, all right, a die. So die, I would say that what all the six, all the six, um, all the six all the 6 possible outcomes are equally likely to occur. All right, so one has the same chance as a 2, 2 has the same chance as a 3, 3 has the same chance as a 4, 4 has the same chance as a 5, 5 has the same chance as a 6. All right, so all the 6, so equally likely event means that every member, every simple outcome of the experiment has an equal chance of occurring. Okay, you can also think about, let's say, a coin, right? all the two possible all the 2 possible outcomes as equal chance. So each one of them has equal chance of occurring, right? If you think about a coin, you have a head and then you have a tail. A head has the same chance as a tail. All right, a head has the same chance as a tail. So those are like some example. So as long as the event, each outcome of the experiment has equal chance of occurring, then we say that they are equally likely event, and you can easily pair that to when we're dealing with simple random sampling, where each member of the population has equal chance of being represented in the sample. Okay, now anytime you have equal likely event, all right, then the way you calculate the probability, is that you count the number of events, the outcome for the particular event, and then you divide it by how many things are in the sample size. So probability of the event is number in the event divided by the things in the sample size. We will take some examples very soon. Before we move on, and we would see this later on today, as long as we have equal likely event, the way we calculate the probability is called classical or theoretical probability. Okay, and we'll have a chance to talk a little bit about this very soon. As long as the outcomes are equally, as long as the outcomes are equal likely events, all right, then this is how you can calculate the probability. Count the number of outcomes in that event and then divide it by the total number of outcomes in the sample space. If you do this, these things that I've written here, if you do this, all right, now when you are doing something like this, it means that you don't need actually to perform the experiment, because you know how many things you can, like, you don't have to go and buy a card when I ask you what is the chances that, or what is the chances that you will get a hat, or you don't have to go and buy a die if I ask you what's the chance of getting an even number, or you don't really need to own a coin if I ask you what's the chance of getting a head. All right, so all those, because each of the outcome is equally likely, the method that you use to calculate that probability is called classical or theoretical. Like theoretical, you don't have to perform the experiment, you know it based on theory. Okay, so these are some examples of equal likely event. So here, each one of these example is called classical or theoretical probability. So when you are calculating the probability based on theory, all right, in theory, we know that if you throw a coin, you could get a sample space, sample space. You get a sample space of a head or a tail. And then this question says, find the probability of getting a head. So you don't have to perform this experiment. You know there is only one head. So here, number in the sample space is 2. Number in event E is 1. There's only one head out of the 2. So in theory, that will give us 1/2. And that is called classical probability. That is called classical probability or theoretical probability. All right, let's look at another example. Now it says that in the next example, it says that what? It says that two unbiased coins are tossed. What's the probability of getting at most? So if you toss 2 coins, and I'll show you how you could create the sample space. So it could be head, 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 tail, tail, head, and tail, tail. So number in the sample space will be four simple outcomes. All right. Now this says find the event of getting at most one head. At most one head. So this is good, this is good, this is good. So your E, it's at most, sorry, I made it. This is 2 heads, so I'm wrong here. I highlighted two heads instead of um, at most one head. So no head is also okay. All right. So what you would see here, the number in the event is what? 3. So you're going to have 3 over 4. You don't have to go and get 2 coins or so and toss it, right? You know this by theory. So that is also classical probability. Another example, it says you toss an unbiased die. You toss an unbiased die. So here you don't have to go and buy a die, and then because you know that the sample space will be 6, right? In theory, n of s is 6, and you can list them out. Now the question says, find the probability of getting a multiple of 3. A multiple of 3, something that 3 can divide. So that could be 3 and 6. So here, you know how many things are in E? There are 2. So that would be 2 over 6, 2 over 6, and then that gives you 1/3. So once again, that is a classical probability or theoretical probability. Why is it theoretical? Number one, because each of these outcomes are equally likely to occur. All right, each of the outcomes are equally likely to occur. All right, this is equally likely to occur. I don't like this color. All right, each of the outcomes are equally likely to occur. So each one of these is equally likely not that one. Each one of these are equally likely to occur. Each one of these are equally likely to occur. Okay, and when you have a probability where each outcome is equal likely to occur, what do we call it? We call it classical or theoretical probability. All right, we call that classical or theoretical probability. You don't have to go and actually buy the things for you to know the answer. You know the answer based on theory. All right, you don't have to perform the experiment. Okay. Now, so additional example of equal likely event is what I have here. All right. So now this time, it says one card is drawn from a well shuffled deck of cards. What's the probability of an ace? So we know there are 4 aces out of 52. Then you reduce it. A face card. Now no face cards are king, jack, and queen. All right. So 3 in each set. 3 in each set. So there are 12 of them. So that is 12 out of 52. Now this question says a red 10. A red 10. A red 10. A card that is red and it is 10 at the same time. So I have one here. I have another one here. So we have 2 of them. So that'll be 2 over 52. 2 over 52. Now the next one says a diamond. Now, diamonds are the whole of the set, right? So that will be 13 out of 52. Now, this says not a diamond. Not a diamond. So all the values that are not diamonds, right? Everything that's not diamond. So you have 39 cards that are not diamonds out of 52. Then the next one says a red card. A red card, now 2 sets are red, right? So this set is red and this set is red. So 13 plus 13, that gives you 26. So you have 26 divided by 52. And then the final one says that there's what? These a king of spade, meaning that you are looking in only the spade. All right, so you're looking in only the spade and you are selecting the king over there. All right, the king of spade. The king of spade, it's only one, right? One out of 52. One out of 52. For each question, you have to reduce the answer. Right, just writing it here so you can reduce that later. Okay, so that is how, as long as so all the deck of cards, each one is equally likely, right? So each outcome it's equally likely to occur. Okay, so anytime you have an experiment where each outcome has an equal chance of occurring, then it is an equal likely event. And if it's an equal likely event, then you have an empirical or classical probability. So all these are example of sorry, all these are example of classical or theoretical probability. Okay, now um, many times we use what we call a tree diagram. We use a tree diagram to determine the sample space or to write down all sample space. Okay, so a tree diagram is a tool that is used to visualize or and list all the possible outcome of a sample space in a random experiment. Okay, so what I'm going to show you is how do you use a tree diagram. Okay, so I have an example here. Um, Suppose you flip two coins. You flip two coins. All right. So the first coin can be heads or tail. The first, okay, let me say, can be tail or head. The second coin can be tail or head. So this is how you do. Let's say coin A, it's a tail or head. Um, Coin B is tail or head. So you're gonna do, because there are two outcomes, you're gonna do something like this. So tail, head. Then from each one of these, you're gonna branch it based on the number of outcomes in coin B. So there are two, so tail, then head. Tail, then head. Then when you finish, you're gonna list them from left to right. So the outcomes, so the outcomes, this will be tail, tail. This is equal to tail, tail. Then you go again, that will be what? Tail, tail, head. Then now you go to the next line, that will be head, tail. Then you go to the final line, that will be that will be uh, that will be head, head. So you can list all the sample space. So the sample space has been listed here for us. The sample space has been listed for us. Now, it doesn't have to be only 2 coins. It can be 3 coins. So let's look at the next example quickly. All right, so when we have 3 coins, so the first coin could be head, tail. Actually, I'm using tail first and head. So let me say consistent. Tail, head, tail, head, tail, head. Right, so coin A is tail, head. Uh, Coin B is tail, head. Coin C is tail, head. All right. So as far as coin A is concerned, this is coin A. That is for coin A. All right. So you do something like this, tail, head. Then from each outcome, you're gonna do the. There are only 2 here, so you're gonna do 1, 2, tail, head. Then 1, 2, tail, head. Now, then that is for coin B, right? That is for coin B. So this is for coin B. This row was for coin A. This is for coin B. All right. Now, you're going to start with coin B, going to coin C, then you do tail, head, tail, head, tail, head, tail, head. All right. Now, then you trace it. So you have tail, 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 you write it. Then tail, tail, head, you write it. Then tail, head, tail, you write it. Then tail, head, head, you write it. Then you come over here. Head, tail, tail, you write it. Then head, tail, head, you write it. Then you come over here. Head, head, tail, you write it. Then you come over here. And then after that, you list all the outcomes, and then that gives you the sample space. So that's how to use a tree diagram. Now, the final portion of things that I want to let you know is that there are three methods of calculating probability. I've spoken extensively about the first one already, which is um, the classical approach. In the classical approach, all the events are equally likely. Equally likely events. Every member of the sample size is equally likely. Empirical approach, it's when they actually take a survey or something like that, and then you are getting your information from that. Subjective is when you are applying intuition. So we've talked about equal likely event already. So in empirical, it's based on like a survey, all right? It's based on a survey. So here, a survey or historical data. A survey, historical data, or experimentation. They actually toss a coin or something like that. All right. So based on a survey, and it is based on relative. If you remember how we did relative frequency, all right, the total sample over whatever they are interested in. So a travel agent determines that in every 50 reservations she makes, 12 will be for cruise. So what is the probability of the cruise? The 12 out of the 50. Then you write it. So this is an example of empirical. Let me also state that they can give you a frequency distribution because empirical is just relative frequency actually, right? So they give you a frequency distribution and they say what is the probability that is between um, 26 to 30. So this number over the total, 8 over that, and then you write the probability of that. So it's just relative frequency. That's empirical. All right. Now the final one that I can say, it's subjective probability. In a subjective probability, here you are using a degree of belief like educated guess. Okay, so when a doctor says that I feel the patient has 90% of full recovery, that subjective is based on their opinion. So you reflect the person's opinion, intuition, best guess about whether the outcome would occur. All right, so my time is all spent, but this is what I'm leaving with you, that there are three methods of probability: classical, which is the same as theoretical; empirical, which is the same as relative frequency; and then subjective. Okay, so I would see you on Friday.